Right. Please subscribe to my channel. Then only you will get the all notification in future. If I will upload any videos, also directly you will get into your YouTube. Right. Thank you. Next. So here in the previous class we discussed about the what is the SD means side distance and what are the different types, right? And I gave a brief introduction about the each and every type, right? The SD is different types. One is SSD, stopping side distance. Another one is OSD, next side distance at intersection, right? Next ISD, intermediate side distance. Next another one is HLSD, headlight side distance, right? So here now we will discuss deeply about the what is the SSD, stopping side distance, right? See here, simple. See here we have one vehicle, right? See here we have one object. So here to stop this vehicle without collision with this object, so how much distance we required, the minimum distance we required, that is SSD, stopping side distance, right? Clear. Look here, look at the definition. SSD is the minimum side distance available on highway at any spot having sufficient length enable to the driver to stop the vehicle traveling at design speed safely without collision with any other obstruction, right? Clear. So here the SSD mainly depends upon the feature of the road ahead, means here how the road is there, right? Next, another dependent is the height of the driver. Here the minimum height of the driver from the object to that road is 1.2 meter. This value is according to IRC. Then only we are considering the SSD, stopping side distance. The minimum side distance is we are calculating only if the height of the driver's eye above the road surface is 1.2 meters, right? Next, here this is the 1.2, right? Next, here we have object, at least minimum object is we have to observe, that is 0.15 meters, right? So here the height of the object above the road surface is 0.15 meters. In coming picture I will show the details, right? Look here, look at the criteria for measurement. See here, this value must be 1.2 meters. This value, this object value, minimum 0.15 meters. See here, more than the value also we can observe, but the minimum distance is 0.15 meters. That's it, right? Next, what are the factors affecting the SSD? See here, these five factors majorly affect the SSD. These total 5 points are most important, right? So here, what is the first point? Total reaction time of the driver, right? That factor is depends the affect the SSD. Next, speed of the vehicle. If the speed of the vehicle is more, definitely SSD value also more. Next, efficiency of the brake. See, if we have a good efficiency for the brakes, then my SSD value must be less, right? Next, frictional resistance between the road and tire. Definitely, see here, the longitudinal friction value is 0.35 to 0.40. Next, gradient of the road. Definitely gradient is also affect the SSD. Maybe gradient may be up the slope, gradient may be down the slope, right? So here, if the gradient may be up the slope, definitely the SSD value is less. SSD value is less, right? Clear? Up the slope SSD value is less. For down the slope the SSD value is more. What is the formula? In the future classes we will know, right? Next, one by one to how the factor is affect. One by one we want to know. What is the first one? Total reaction time of the driver. Means what is the reaction time of the driver? See here, reaction time of the driver is decided by based upon the PIV theory. PIV theory. Look here, this is the PIV theory. The total reaction time of the driver is split into four parts. Means here, if I know these four values, then if I will add all the values, then I will get the total reaction time of the driver. Total reaction time of the driver. So here, what is the first one? Perception. Second one, intellection. Third one is emotion. Fourth one is volition, right? So here what is the perception? Means, see, for example, first we have to react. How we are reacting when we see the object? Definitely, see here, first we have to percept. Means first we have to understand the, means first we have to look at the object. That is the perception, right? Perceive. Clear? Next, see here, intellection means we will think in the brain. We will think in the brain. Next, volition. Emotion is also output, right? Here volition is the break, break लगाने का time, right? Here how much time required to apply the brake, that is the volition, right? Look here, simple. See here, this is the brain. So first we have to perceive, right? Next we have to think, that is intellection. Next we have to tell the output, that is emotion, right? So here next, volition means how much required, how much time required to apply the brakes, that is volition. Clear? That's it. Next, if I will directly take, that is a reflection time. This reflection action time, right? That's it. Clear? Next, right, this all this will explain about the reaction time, right? Perception time, break reaction time, right? So here perception time, first we have to understand. Next, break reaction time, right? Clear? Next, right, see here, actually the total reaction time of the driver may be vary from 0.5 seconds to 4 seconds. Actually this will happen, but while designing, as per IRC, Indian Road Congress, we are taking reaction time for SSD is 2.5 seconds. For OSD we are taking reaction time, total reaction time is 2 seconds. 2 seconds. That's it. Next, analysis of SSD means, see here how we are determining the SSD, right? I need some figure, sorry, I need some space. Oh, sorry. Right, I will try to derive here, right? So here how we are deriving the SSD means, what is the total time for total distance for SSD. See, for example, here we have one vehicle, right? Here we have one object, right? So here the minimum distance required when we observe this vehicle, that is SSD. Total distance is SSD, stopping sight distance, right? So here maybe this vehicle is having some speed, right? Clear? So here definitely after some time my vehicle I want to stop. That's why here my vehicle may be here, means final velocity will become 0. Final velocity will become 0, right? So here, see here, this total side distance we can divide into two distances. That is, one is log distance, another one is braking distance. This is the log distance, this is the braking distance, right? This is LD, this is BD, braking distance and log distance. What is the log distance? Simple. See here, log distance means, see here, first we have to perceive the situation. Yes or no? First we have to perceive the situation. That is the perception, right? So here, while perceive how much distance the vehicle is traveled, that is log distance. Clear? So here the distance value directly we are calculated as, for example, we know one formula, that is speed is equal distance by time. Then what is the distance? Distance is equal speed into time. Clear? So here distance log distance is equal velocity into time. So which time? Reaction time. This is the log distance. Right? Clear? So here what is the V? speed of the vehicle, that is in meter per second. Then what is the TR? Reaction time. So here we are calculating for SSD, the value is 2.5 seconds. 2.5 seconds, that's it. Next, what is the braking distance? See here, maybe here this is the log distance. Next, braking distance is there, right? Means after perceive, we have to apply the brakes. So here, while applying the brakes, how much distance that vehicle is traveling, that is the braking distance. That is the braking distance. So here this is the log distance. This is the log distance, right? Already calculated about the log distance. Then how we are calculating the braking distance? Braking distance, here we have one formula, that is v square minus u square is equal to 2as. So here what is the v? Final velocity or final speed. This is what is the u? Initial velocity. Acceleration, here distance or displacement, right? So here this value will become 0. Why? Because after applying the brakes, my velocity will become 0 finally, right? So here final velocity will become 0. So here we have u square, means u means initial velocity. So here what is the initial velocity we are considering for the vehicle? That is v, right? So here minus v square is equal to what is the a? Acceleration. What is the a? Acceleration. But here we are applying the brakes, then what will happen? Retardation will occur. So here that is mu into g. Then what is the s? The displacement value, means how much distance is changing. So here that may be braking distance. That may be braking distance. Then minus minus gets cancelled. Then what is the LB value here? LB directly I can calculate as v square by 2 mu z. V square by 2 mu z. That's it, right? So here I can derive the formula for SSD is, so here SSD I can derive as by taking the sum of the log distance and braking distance. What is the log distance value? V into TR. What is the braking distance value? Just now we calculated, right? So here v square by 2 mu z. So here what is the v? Velocity of the, sorry, speed of the vehicle. So here TR is the reaction time. Here also speed. Here the coefficient of friction. Here G is the gravitational value, right? Right? Clear? Acceleration due to gravity. That value is 9.81. Right? Here velocity is in meter per second. Speed is in meter per second. Here TR is in seconds. That's it. Clear? Right. See here the formula is in kmph, right? I derived in meter per second, right? So keep in that mind, the value is directly you take in only meter per second. That is easy for you while doing the problems, right? Next, this table is also important. See, if the coefficient of friction value is not given, so then we want to take from this table. Here these all are speeds of the vehicle. For example, in the question he will give the value 60 kmph, then mu value is not given. Then what is the mu value? So 0.36. See, remember like this. Here if we have more than 80, directly we have to take 0.35. Why? Because mu value is starting from 0.35 to 0.4, right? Minimum 0.35, maximum 0.4, right? So here if the speed is more than 80 kmph, then we have to take 0.35, 60 kmph, 0.36, 50, 0.37, 40, 0.38, then 30, 0.40. That's it. Next, see here, for example, this is the road, right? See here, this is the one lane, right? See here, one lane with two-way traffic, then what is the SSD value here? See, for this vehicle this is the one SSD value, right? For this vehicle this is the SSD, right? So here if in the question he will give two-way traffic with single lane road, then calculate the SSD. In that situation what will happen? SSD value will become 2 into SSD. Why? Because two-way traffic for this vehicle, this is the SSD, For this vehicle, this is the SSD. Then what is the total SSD for this condition? 2 into SSD. SSD plus SSD. 2 into SSD. That's it. Right? Next, if we have one-way traffic, then what will happen? Right? So here both are same SSD, right? For this case SSD, this case SSD. Then is in this situation, what is the SSD value? Only SSD. Only SSD. That's it. Right? If we have two-way traffic with two-lane road, then SSD value become only SSD. Right? If two-way traffic with single lane road, then SSD value will become 2 into SSD. That's it. That's it. Right? So here these all are the examples. Directly you can try it. Right? See here. Right, I will try to do first problem. Calculate the safe stopping side distance for a design speed of 50 kmph for two-way traffic on two-lane road, two-way traffic on single-lane road. Then what is the first question? First question, directly we want to calculate SSD. Right? What is the second question? That is B. Right? Two-way traffic with single-lane road. That in this case, what will happen? 2 into SSD will become SSD. Stopping side distance. Clear? Clear? Right. Next, what is the formula? VTR means log distance plus braking distance. V square by 2 mu z. See here mu value is not given, but here given that 50 kmph. Then what is the mu value? 0.37. 0.37. Right? Directly you have to substitute. What is the G value? 9.81. Then what is the velocity value? So speed value is 50 kmph, right? So first convert into meter per second, right? How we are converting? Simple. See here, 50 kmph, kilometer per hour. So 1 kilometer is equal to 1000 meters. 1 hour is equal to 60 into 60. 0 0 0 0 gets cancelled, right? So here 2 5 ja, 2 3 ja, 3 6 ja, 18. Right? So here 5 by 18 means 50 into 5 by 18 value gives the value is in meter per second. So here substitute all the values, then you will get the SSD value. Right? Clear? Next, what is the first question? Two-way traffic with two-lane road. Directly SSD value will become SSD. That's it. Right? Next, in the second case, what will happen? In the second question, what will happen? Two-way traffic on a single lane road. Right? In this situation, what will happen? So here SSD will become 2 into SSD for this condition. Right? Just now I told why we are getting 2 into SSD. Just now I told, right? Please go through the 3 minutes back if you will get doubt. That's it, right? Then you will get the answers. Same way, try for this question and